Assalamu alaikum. In this video, I will be showing you how to simulate circuits using LTspice. You will be using LTspice to simulate circuits in your group activities assignment, in which you have to verify the answers of a problem of solving a circuit manually. You have to verify that using the LTspice, right? So in this video, I will show you how we are going to simulate the circuits that we have done in our previous video, which is practice problem 2.5 and practice problem 2.7, right? So before you can actually run this software, you have to download it first to your PC. So to download that, you have to search the download LTspice here, okay, and then press this LTspice Design Center Analog Device, and then you will reach this page here, which is the similar page as I showed earlier. Okay, so there are two versions of LTspice available here, which is the Windows 7, 8, and 10, as well as for the Mac OS 10.9 upwards. Okay, so you can download depending on the type of operating system that you use for your computer. Once you have downloaded the software or the program, you can install it, run the setup program, and install it to your PC. Okay, so the circuit that we are going to simulate is practice problem 2.5, which consists of 2 voltage sources and 2 resistors, as well as practice problem 2.7, which consists of the current source, 2 resistors, and a dependent current source. Alright, so let's do the first circuit here. We already have solved this circuit to find V1 and V2. We have calculated it before. For those of you who have not seen the video yet, please watch the previous video first before you can proceed with this video. Alright, so we have calculated this, and we have found out that the values of V1 is equals to 16 volts and V2 is equals to minus 8 volts. So we are going to verify this using LTspice. Once you have installed the LTspice, you have downloaded and installed it to your PC, you can now run LTspice. So this is the window that you will get after you run the LTspice. In order to simulate the circuit, we have to construct the circuit first. So we have to press this button here, which is a new schematic, in order to start constructing the circuit or drawing the circuit here. Okay, so what I'm going to do now is I'm going to just put the elements first on this blank schematic here, which in our first case is 2 voltage sources and 2 resistor. You can do that by pressing this button here. This is a shortcut for some of the elements. For example, a resistor, a capacitor, an inductor, a diode, and so on. Alright, and if you press this one, then it will show you all the elements which are available in LTspice. Okay, so the voltage source that we need, if you scroll to the right hand side, you have a voltage here. Choose that voltage. Okay, just press OK. We need 2 of this voltage source, V1 and V2. However, if you look at this circuit diagram here, the second source here is upside down. You have a positive here and a negative there, which means that while you are still in this mode, press Ctrl R to rotate the voltage source. Right? So you have a second source here, and then press escape to end these voltage source here. And then we have to add two resistors here at the top and at the bottom circuit here. Okay, so you can either go to the list of components here, or you can just press that shortcut button there, a resistor, and then you have the resistor there. Now LTspice will initially place the positive default terminal of the resistor at the top of this resistor, which means that the positive terminal of the resistor will be here and the negative terminal is going to be here, right? In order to construct this circuit here, I have to rotate this resistor. So to rotate the resistor while you are still in this mode, you just press Ctrl R. If you press Ctrl R once, then the component will be rotated 90 degrees in a clockwise directions, which means that you have a positive terminal here and you have a negative terminal here. You press Ctrl R for the second time, then the component will be again rotated by 90 degrees, but now you have the positive here and the negative there. And finally, if you press another Ctrl R, then you have the positive terminal here and the negative terminal here, which is actually what we want here, right? You want to have a positive terminal of the resistor 4 ohm there and a negative there. Okay, so I'm just going to place that, and then I'm going to place the second resistor here, which also has a positive terminal on the left hand side and the negative terminal on the right hand side, and press escape to end that. Right, now you can connect all these components here by using the wire here. Let's connect there. Or you just can, you know, go through the elements, because LTspice will automatically will not be connecting that two terminals of the elements there, but rather it will bypass the elements. Okay, so you just press that, and then you can go through the elements here, and then finally connect to the negative of V1. Alright, so we have a complete circuit here. Before we can actually simulate the circuit, we have to add the reference point, because in order for the PSpice to simulate, you have to have a reference point, okay, which is the ground. In order to zoom out, you just scroll your mouse, or you can press your space bar to fill in your windows, something like that. Right, so I'm going to zoom out here, and then I'm going to place the ground here. Right, so let's place the reference there, and then connect the reference to the circuit. Alright, so let's change the values of the voltage sources as well as the resistor to the value here, 32 volts, -8 and 4 and 2 ohms there. So the first one is we're going to change the voltage source here, so you just move your cursor to V there, right click it, and then change to 32 volts. And then the second source to -8, and then this resistor to 4 ohm, and you have a second resistor to 2 ohm. Alright, the voltage source not only is capable of simulating a DC source, but also other type of source, which we are going to talk that perhaps later in the later part of the course. Before we can actually simulate the circuit, we have to tell LTspice what type of analysis that we want to perform. So to do that, you go to the simulate, then you edit the simulation command here. For CLO2, we are going to use this DC operating point type of simulation. For CLO1, okay, we're going to use the DC operating point type of simulation. For CLO2, we are going to use the transient, and for CLO3, we are going to use the AC analysis. So let's go back to the DC operating point analysis. Just click OK there, and then you can place the SPICE directive anywhere on this schematic. Let's place that somewhere here. Okay. Now you can run the simulation now. Okay. Save the circuit first. So File, Save As. Choose your directory here. For example, if I want to name it as example 1, for example. Okay. And then once you save the circuit, then you can see the netlist of the circuit. A netlist of a circuit is how SPICE in general describe the interconnections of the elements in a circuit using text file. To look at the netlist, you go to the edit here, you go to the view, and then you go to the SPICE netlist. This is the netlist for this circuit here. Alright, the V1, which is the voltage source there, is connected between 0, which is the ground node, and N001, which is that node there. Okay, so PSpice will automatically name the node, the first node as N001. And then we have V2 there, which is the second source there, which is connected between N003 and N002, and the value of the voltage is -8. Okay, and then for R1, remember the positive terminal is on the left hand side, so you have N001 and N002, which is the negative terminal. The value is 4. And then similar to this one here, we have 0 here, which is the positive terminal, the ground, and then we have N003 on the left hand side here, and the value is 2 ohm. Okay, so this is this is what we call the netlist for this circuit that we are going to simulate here. Okay, it is important to know this netlist, because from this netlist we can obtain the voltages and the currents of the elements across the elements and through the elements that we want. And it is if the circuit consists of several nodes. For example, in these circuits there are only 3 nodes plus one common or one reference node 0 here. But if you build a more complicated circuit, then you probably have more nodes, which is going to be very confusing to read. All right, so instead of letting PSpice to name the node automatically, we can force PSpice to name the node according to what we want. For example, instead of N001 here, I want this node to be named as A, and then instead of 002 here, I want the node to be named as B, and instead of N003 here, I want it to be named as C. So we have A, B, C there. Alright, so to do that, you have to close this first. Okay, you move your cursor to the point where you want to name the node. Just right click it and then label the net here. Okay, just call it A and then place it to the node here. This is the second node that we want to name. Just place A first and then we will rename that later. Right, and then we have C. So A, B, C, press escape to end that. And then you move your cursor to A, the second A here, right click it and name it to B. Right click to the second A here and name it to C. So the nodes now will be named as A, B, C instead of 1 and 001 and 002 and N003. So if you save it and then look at the netlist again, Spice netlist, you will see that the node now will be named as A. V1 is between 0 and A, and V2 is between C and B. Okay, R1 is between A and B, and R2 is between 0 and C. Okay, now we can now run the simulation by pressing that button here, or you can go to simulate and then press run here. Alright, so this is the results that we obtained from the simulation. VA, which is the voltage A there, with respect to 0 is 32 volts. Okay, VB, the voltage VB there with respect to the reference there is 16 volts. And then we have C, the voltage C there, which is VC there, with respect to that reference is 8 volt. Okay, and this is the current which is flowing in all the elements. We have IR2, current from left to right, okay, is -4, because the actual current that we have calculated is positive in that directions. All right, positive in that directions, which have +4, which is the reason why we have -4 there, because the current, as I said in PSpice, the displayed current there for R2 is from positive to negative terminal, which is going that way. And then we have IR2, which is current going into the positive terminal from left to right, is 4 ampere. For the current, for the voltage source 1, the current is going from positive to negative terminal, which is going to be -4. Okay, as well as for the voltage source 2, we have a current going from that positive to negative, which is the reason why we have -4 as well. Okay, so the voltage that we are interested in is voltage across V1, which is across that one. What we have is the voltage VA with respect to the reference and VB with respect to the reference. If we want to display the voltage across AB, we have to subtract voltage VA with voltage VB. All right, and in order to do that, we have to add the VA minus VB into the circuit. For example, if I press this wire here, right click to the wire here, then I get the voltage VA with respect to the reference there, which is 32 volts. All right, now if I right click that, okay, you can see that now I can edit the expression of the voltage that I want to display, which means that I want the voltage to be VA minus VB. All right, and then I just click OK there. So you have 16 volts. So you move that somewhere here, for example. All right, so that is the voltage across that, VA minus VB, which is VAB. Next, I want to display the voltage across R2, which is that voltage there. Okay, plus minus. I know that the voltage is equals to -0 minus VC, or equals to -VC. All right, So if I click that point there, then I'm displaying the voltage VC with respect to 0, right? What I want is a voltage 0 minus VC. So I will click that and then change it to 0 minus VC. Click OK. Then you have minus 8. Right now I'm going to move that that to somewhere here. Right, so I'm going to add text to say that this is VAB and this is V minus VC, right, which is a voltage across that R2 there. So to do that, you go to the op here, spice directive, and then you click the command here, and then you say this is VAB is equals to that, and then you can just place that somewhere there. Okay, and then we have the second voltage here, which is V minus VC. Again, you can just you just use that, select comment there, and then you have minus VC there. Oops, sorry, minus VC equals to that. Okay, let's say that you want to change the values of this resistance. You can do that by right clicking that say you change it to 6 ohms instead of 4 ohms, and then you can run this simulation again, and then you will get a new results with the new values of resistance R1. All right, now you have 18 and minus 6 instead of the previous values that we have seen just now, which is 16 and minus 8. All right, let's change back to 4 here, and then run the simulation again. All right, now the other thing that we want to find out, for example, is we want to find what is going to be the current through that element there. Well, you can do that by if you just put your cursor to the element there, and then you can see that at the bottom of the circuit, sorry, the left bottom of the circuit, you see that says the operating point IR1, which is the current through R1, is 4 ampere, and it also gives you the power the dissipated due to that resistance, which is basically equals to I squared times R. All right, and then if you move a cursor down here, then you will see that the current is -4, in which it is to what we have expected, because the positive terminal of R2 is on the left hand side here, and the positive current is flowing into the negative terminal here. Okay, so we have a -4 ampere going into the positive terminal of R2, which is in which the positive terminal is on the left hand side of R2. All right, in order to display the current, for example, if I want to display the current that through that R1 there, what I can do is I can first display the voltage here. Okay, and then right click the voltage, 32 volts, and then change it to the current IR1 here. Then click OK. Then I'll get the 4 ampere flowing through that resistance there in that direction. Okay, what is the current flowing through R2? You just right click there, you have the voltage of VC with respect to the reference, change that, and then choose IR2, and then you have sorry, I have to remove that $sign first. Okay, and then you have -4 ampere. and you know this for -4 ampere is actually the current flowing from that, from the left hand side to the right hand side of R2. Okay, you can also view the current through that voltage source again by just placing your cursor to the voltage source, and you can see at the bottom right hand side of the windows it says you have a -4 ampere current flowing into the positive terminal of V1, because the positive current is going out of 4 ampere, which is the reason why you have a -4 ampere there, as well as the power dissipations of -128 watt, which means that a negative power dissipation, meaning that the voltage source is actually supplying 128 watt of power. Okay, and then we have the power here, power dissipations there, which is 32 watt of power dissipated there. All right, and then we have the power dissipation here, which is 64, and then as well as 32 watt. Okay, so 64 plus 32 plus 32 is equals to 128. So you have a zero total power of the circuit is what we expect, which is equals to 0 watt. So that completes the simulations of practice problem circuit for the practice problem 2.5.